Hi everyone. Today's lesson is on using special triangles to find exact trig values. So the angles 30, 45, and 60 and their related angles in quadrants 2, 3, and 4 are benchmark angles that are used frequently in the study of trigonometry. For this reason, it is important for mathematicians to know and memorize their associated trig values. Okay, and when we do this, we want the exact trig values, not a decimal approximation. So we're gonna work these out. So first let's examine the 45-degree special triangle. So if you look at this special triangle the way it's drawn right now, it's showing you that they've drawn it so that the radius is 1. And we're gonna do that for all of our special triangles. And this special triangle you can see is 45 degrees, and here's my point. It's gonna be something, something. So over this much and up this much. But you can see that if this is 90 and this is 45, and all the angles in a triangle add up to 180, then this one's 45 as well, which means this is a special triangle. It's an isosceles right angle triangle, which means these two sides are the same. So this length from here to here is x. Y is also going to equal x because it's an isosceles triangle. And we know r is 1, so we can use our Pythagorean relationship that r squared equals x squared plus y squared to figure out the length of x and y. So r is 1, we'll leave x as x squared, but y is the same length as x, so I can change y to x. And then 1 squared is 1, x squared plus x squared is 2x squared, and now I can solve for x, which will also be our y value. So I can use reverse BEDMAS here, so I can divide both sides by 2, and then square root both sides. We're in the first quadrant right now, so we won't worry about the plus or minus, and I'll show you later where that comes into play in this lesson. So we've got that x is going to be, and I can break this up into the square root of 1 over the square root of 2, because the square root of 1 is 1, and root 2 does not have a nice root, so we would leave it as root 2 because we're worried about exact values here. So that means that this distance here is 1 over root 2, and this distance up from here to here is also 1 over root 2. So y is also 1 over root 2. And this point then along the terminal arm, if we cut it off here, would be 1 over root 2, 1 over root 2. Now what does that mean? So that means we can get, for instance, so what does it mean when it says exact trigonometric values? For instance, that means what is the exact value of the sine of 45 degrees? Okay, well, if we go back to angles in quadrants in the CAST rule, we know that the sine of an angle is its y value divided by its r value. We know that the cosine of an angle is its x value divided by its r value. We know the tangent of an angle is its y value divided by its x value. So I can do the same thing here. The sine of 45 is its y value, which is 1 over root 2, over its r value, which is just 1. But dividing something by 1 leaves it the same. So the sine of 45 is just exactly 1 over root 2. So let's prove that to ourselves on our calculator. So make sure your calculator's in degrees. And I want you to type in the sine of 45 degrees and press equals. And you get this decimal 0.707106781. So even though it gives you a lot of decimal places, you could copy them all out, but it would still be rounded to the 8th or 7th decimal place here. Now let's see if 1 over root 2 gives us that same decimal. 1 divided by square root of 2. Exactly the same decimal, 0.707106781, but this is an exact number, unrounded, 1 over root 2. Okay, not a decimal approximation. So the cosine of 45 degrees is the x value divided by the r value. So 1 over root 2 over 1 again, but we know dividing by 1 doesn't change anything. So the exact value of the cos of 45 is 1 over root 2. And then the tan of 45 degrees is the y value, which is 1 over root 2, divided by the x value, which is 1 over root 2. And when you divide a number by itself, you get 1. Any number divided by itself is 1. So the tangent of 45 is 1. Let's try that out on our calculator. Tangent of 45 is exactly 1. Okay, so there is our 45-degree special triangle, along with its sine, cos, and tan. Now what, for instance, say I wanted its secant. So there's a couple ways to think about it. One of them is that, well, if we know its cosine is 45 degrees, we know that if we flip that upside down, we would get its secant. Okay? Or if you go right back to the definition, sec theta is the upside down of cos, so r over x. So if we looked at it that way, r is 1 over x, which is 1 over root 2. What happens when you divide a whole number by a fraction? You multiply by the reciprocal, so 1 times root 2 over 1, which is just root 2. Root 2 over 1 again, which is just root 2. So this is kind of the easiest root. If you know the cosine of it, you flip that upside down and that will give you the sec. All right, on to our next special triangle. So now we're going to look at the 60-degree special triangle. So you can see there's our 60-degree angle. Here's our point on the outside. So we want to know how long is x in our special triangle and how long is the y value. And we're given that r is 1 again. So if we think about making first of all, a equilateral triangle. So if I join here, this is shown as being 1 here, which means that this whole side here is 1, this is 1, and then if we draw in this third side, it's also 1. So we have what we call an equilateral triangle where these 3 sides are all the same. And then these angles, this is 60 up here, this whole angle, this is 60, and that's 60. Okay, that's what makes an equilateral triangle. So if we drop down this vertical here, we cut this 60 in half, making it 30, but we also cut this side in half. That's a property of bisecting an equilateral triangle. So x is a half. So if we're looking at the shaded special triangle here, which is the one that's important, we now know that x is a half and r is 1. So we know 2 out of our 3 sides, and we can use the Pythagorean theorem to figure out the third side. So r is 1, x is a half, and y we're going to calculate. So 1 squared is 1. A half squared is the same as 1 squared, which is 1, over 2 squared, which is 4. Subtract a quarter from both sides. So 1 minus 1/4 is 3/4. But now we need to square root that. We're in the first quadrant, so we're not going to worry about the plus or minus. But we could change it to the root of 3 over the root of 4, because the root of 4 is 2 exactly. So we know that the y value here, so if I go back again, so this length here is what that y value is. This length here is the square root of 3 divided by 2. Okay? When this length here is 1/2, and this length here is 1. So the point here would be over a half in the x direction, and up root 3 over 2. So we have x, y, and r labeled, so we could figure out the exact value of the sine of 60 degrees. So sine is the y value, root 3 over 2, over the r value, which is 1. Dividing by 1 doesn't change anything. So we're saying the sine of 60 is exactly root 3 over 2. And then let's check that on our calculator. So sine of 60, we get the decimal 0.866025403. But we could also see square root of 3 divided by 2 gives you the exact same decimal, 0.866025403. So the exact value of the sine of 60 degrees is root 3 over 2. Cosine of 60 degrees is x over r, so a half over 1, which is a half. Tangent of 60 degrees is the y value, which is root 3 over 2, divided by the x value, which is a half. Okay? And then when you divide fractions, you multiply by the reciprocal of the second, so the first fraction stays the same. Multiply the tops together and the bottoms together, and you end up with root 3. And something that you may have learned when you divided fractions way back in grade 9 or in elementary school is that if you divide two fractions that have the same exact denominators, the denominators divide out, and you're left with dividing the numerators. And it works out that way a ton in this unit in trigonometry, so it may save you some steps. If you do show this step, then divide the 2's out and you realize it's root 3 over 1, or root 3 is the tan of 60. So let's check that again. So the tan of 60, we get 1.73205, and then let's try root 3. Exact same decimal, okay? So that's our second special triangle. Our third special triangle is the 30-degree triangle. Now, if you notice, the 60-degree special triangle had a 90, a 60, and a 30. The 30-degree special triangle also has a 90, a 60, and a 30. It's just oriented differently. So we still have r equals 1. But if you look at the 60 triangle, the side between the 60-degree angle and the 90-degree angle was a half. So 60 and 90, this length is a half, so the y value is a half. And the length between the 30 and the 90 is root 3 over 2. So the 30 and the 90, so in this case x now is our root 3 over 2. So this point here would have the coordinates over root 3 over 2, up a half. So we didn't have to do a lot of work there to get the 3 sides because it was just a rotation of the 60-degree right angle triangle. We still can do the sine. So the sine of 30 degrees is the y value, which is a half, over 1, so it's a half. Again, check that on your calculator. Sine of 30, 0.5, which is a half. Cosine of 30 degrees is the x value over the r value, so root 3 over 2 over 1, so just root 3 over 2. And the tangent of 30 degrees is the y value, which is a half, divided by the x value, which is root 3 over 2. So again, that same kind of setup happens where we're dividing fractions with the exact same denominators. So the tan of 30 should be the numerators divided, so 1 divided by root 3. Let's check that. So tan of 30, 0.57735, and then 1 divided by the square root of 3, 0.57735 again. Okay? All right, so now we're going to use special triangles to determine the exact value. Okay, so this idea of exact value, so not a decimal approximation, but exact value is why we're using special triangles. And we're going to draw a labeled diagram of each angle in standard position, so that goes back to what we did yesterday. So we want the exact value of the cosine of 120 degrees. So how do we go about doing that? So first of all, we want to know which quadrant 120 is going to be in. So we know we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, and we know this is 0, benchmark again, 90, 180, 270, back to 360 again, and we knew that the halfway points, if you remember, were 45, 135, 225, and 315. Those were the halfway in each quadrant. And then, so when we draw 120 degrees or when we sketch it, again, we're not going to use a protractor, but we want to put it in the correct quadrant, and then we want to put it either closer to the y-axis or x-axis or right in the middle. Okay? So 120, we can see is not 135, so it's going to end up being closer to the y-axis in quadrant 2. So there's 120 degrees. So what we want to do is we want to choose a point along 120 degrees and draw in a right triangle with the x-axis. And if they ask you for the exact value, so not a decimal approximation, not something you can just type in your calculator, they don't just want the decimal approximation, they want it exact, then alpha, the angle between the x-axis and terminal arm, is always going to end up being 30, 45, or 60, one of the special triangles that you memorize the sides for. In essence, you'll end up memorizing the sides for these. So if this is 120, then alpha in here is going to be the difference between 180 and 120, so it's going to be a 60-degree triangle. So it's going to follow my 60-degree special triangle. So its sides are going to be, its r is going to be 1, r is always positive. Its x value is either going to be 1/2 or -1/2, depending on what quadrant we're in. So in quadrant 2, it makes sense for the x value to be -1/2. And the y value for the 60-degree triangle is always going to be √3/2 or -√3/2. And in the second quadrant, it makes sense for it to be positive √3/2. Okay, so if you think about getting to this point from 0, 0, you're going 1/2 in the negative direction, so over -1/2, up √3/2 to get to that point there. So we've got our sides labeled x, y, and r. Okay, so now that we've drawn in our angle, figured out alpha, drawn our special triangle, and labeled all 3 sides, it should be then fairly straightforward to figure out the cosine. So again, we know that cosine is the x value divided by the r value. So it would be -1/2 divided by 1 x over r. So we're kind of using that idea that cos of an angle is the x value divided by the r value. Okay, oops, I went up too high there. Cos is the x value divided by the r value. And when r is 1, dividing by 1 doesn't change anything. So there's our exact value, and that's the work we would need to show that we use special triangles. Okay, so sine of 315. So again, if you go back to this diagram here, 315 we see is right in the middle of quadrant 4. So we would want to make this look like it's right in the middle of quadrant 4, the best way we could. Here is our angle, 315 degrees. Then we want to draw to the x-axis making a right triangle. And then this right triangle is either going to be a 30-degree triangle, 45, or 60. In this case, since this is 315, the angle between the x-axis and the terminal arm is 45 degrees. So we want our 45-degree special triangle. So R again is 1. The x value is going to be either positive or negative 1 over root 2 depending on the quadrant. So for us, it makes sense that the x value would be positive 1 over root 2. And for 45s, the y is also 1 over root 2, positive or negative depending on what quadrant we're in. So in quadrant 4, it makes sense for the y value to be negative. So we've labeled our triangle, our x, our y, and our r. And sine, if you remember, sine of an angle is the y value divided by the r value. So negative 1 over root 2 over 1 is just negative 1 over root 2. Okay, and again, if you want to check using your calculator, you can try sine of 315 and then check that decimal and then do negative 1 divided by the square root of 2, same decimal, so you know that you're right. Now let's figure these out. All right, next one. Sine of 600. Okay, so first of all, the sine of 600 is going to be the same as the sine of an angle that's coterminal with 600. So I'd be thinking in my head, I'm going to do 600 minus 360 because I want to know where to draw it. They're going to have the same sign because they have the same terminal arm. 240. So now I can base my drawing off. I know it has to be at, my terminal arm has to be at the spot where 240 degrees would be. So we know that the middle of this quadrant is 225, so 240 is going to be closer to 270. All right, so first let's draw in 600. So that's going to be all the way around once and then back here. So this is our 600 degrees. Then we're going to pick a representative point along the terminal arm and draw in to the x-axis a right triangle. And this is either going to be a 30, 60, or 45 degree triangle. So if we know this is 240 and this is 180, 240 minus 180 is 60, so this is going to be a 60-degree triangle. It's hard to fit alpha in here, but this angle in here is 60 degrees, which means it's related to my 60-degree triangle. And I know that my r is 1. The x for a 60-degree triangle is either going to be positive or negative a half depending on the quadrant. So it makes sense in quadrant 3 for the x value to be negative a half. And for a 60-degree triangle, the y value is going to be positive or negative root 3 over 2. In the third quadrant, it makes sense for it to be negative root 3 over 2. So I've got my x, y, and r labeled, and my angle labeled. So the sine of 600 is the same as the sine of 240, that's true. And the sine is the y value divided by the r value, so negative root 3 over 2 divided by 1 is negative root 3 over 2. So again, let's check it on our calculator. Sine of 600, you can see negative 0.866 on, and then negative Square root of 3 divided by 2, same. Okay, but this is exact, not a rounded decimal. All right, tan of 150, so we know 0, 90, 180, the halfway was 135. So 150 is going to be closer to the x-axis. So there's my angle 150. Make my right triangle with the x-axis as usual. And then the angle in here is between 150 and 180 is 30 degrees. So it's related to my 30-degree right angle triangle, which you can see for my 30-degree, the x is either going to be positive or negative root 3 over 2. So in quadrant 2, it makes sense for it to be negative root 3 over 2. The r is going to be 1. And the y value for the 30-degree is either a half or negative a half, depending on the quadrant. In quadrant 2, it makes sense for it to be positive a half. So you go left, so negative root 3 over 2, up 1/2 to get to this point here. So now we've got our three sides labeled, and tan is the y value divided by the x value. So the y value is 1/2 divided by the x value, which is negative root 3 over 2. The denominators cancel out. So the exact value of the tangent of 150 should be negative 1 over root 3. You might think at first it's 1 over negative root 3, which is true, okay? But that negative with a fraction, it can be with the denominator, with the numerator, or out front. Usually, they'll always put it with the numerator. So let's try on our calculator, tangent of 150, negative 0.57735. And let's try negative 1 divided by the square root of 3, same decimal. Okay, and then if you're not convinced about if the negative matters, you can do 1 divided by the bracket negative square root of 3, same decimal. Okay. All right, now cosecant of 210. So we still want to put 210 in the correct spot. So we know we've got 0, 90, 180, 270. So it's going to be in quadrant 3, and we know that the halfway point is 225. So it's going to be closer to the x-axis. So here's our angle, 210 degrees. Draw in our right angle triangle with the x-axis. So if this is 210 and this is 180, then the difference is going to be 30. So it's going to be related to the 30-degree triangle. So the r is always 1, so that's good. The x for the 30-degree triangle is either positive or negative root 3 over 2. So in the third quadrant, it makes sense that the x is negative root 3 over 2. And the y for the 30-degree triangle is either a half or negative a half, depending on the quadrant. And it makes sense for it to be negative a half. So to get to this point right here, you would go negative root 3 over 2 and then negative 1/2. So we've got our triangle labeled, and we want the cosecant of 210. So the cosecant, if you remember, cosecant theta is the r value divided by the y value. There's one way of getting it, so we can do it that way. So the r value is 1, and the y value is negative a half. So 1 divided by negative a half multiply by the reciprocal. So the cosecant of 210 is -2. All right, and then how do we check that on a calculator? Because there's no cosecant button on your calculator. So we know that from our identities that cosecant theta is 1 divided by sine theta. So to check our answer, we could do 1 divided by the sine of 210. 1 divided by sine of 210 is -2, which is what we got for the cosecant of 210. Secant of 315. So draw our angle first. Back to 360, and we know from our benchmark angles that 315 is the halfway point here. So here's 315 degrees. Drawing our right angle triangle with the x-axis. If this is 315 and this is 360, then this is 45 degrees is our alpha, our related acute angle. So we're related to the 45-degree angle. So here's our 3 sides. So in the 4th quadrant, well, r is always positive. R is +1. It makes sense that the x would be positive in the 4th quadrant, so we go to the right 1/√2, but our y should be negative. Down 1/√2. So sec is r over x, so we can do it that way. So the r value, which is 1, over the x value, which is 1/√2. So keep the 1 and then multiply by the reciprocal, and you end up with √2 being the secant of 315 degrees. And then to check it, we know that secant of theta is 1/cos of theta. So we could try 1 divided by the cos of 315. 1 divided by the cos of 315 is 1.4142, and we'll compare that to √2. Same decimal, so we're right. Okay, cotangent of 840 degrees. So I know that 2 times around is 720, and I know 840 is bigger, so I'm going to right away go to subtracting 360 twice. You might take 2 steps to do that, but that's fine. So I'm just trying to figure out again where I'm going to draw it, what quadrant I'm going to draw it in. So I'm doing 840 minus 360 minus 360 again is 120. And we know the halfway here is 135. So the cotangent of 840 is going to be the same as the cotangent of 120 because they have the same terminal arm. And we know that 120 is going to be drawn in the 2nd quadrant closer to the y-axis. So, but if I'm drawing 840, I have to go around 360, 360 again, and then 120 more. So that's 840 drawn there. And now I'm going to draw my special triangle. So this angle in here is going to be, if this is 120 and this is 180, then this angle in here is 60. So we're related to my 60-degree special triangle, which has these sides. Okay, so the R is 1, x is either going to be positive or negative a half. So it makes sense in the second quadrant for x to be negative a half. And for the y to be positive, and in this case it's root 3 over 2. And with 60 and 30, I always like to think of root 3 over 2 is the longer side, because root 3 over 2 is like 0.866 approximately, and a half is 0.5. So the longer side is the root 3 over 2. It's a bigger number. Okay, so now we've drawn our picture accurately. So our cotangent is going to be, so we have to remember again, back to our angles and quadrants and cast rule, that the cotangent is the x value divided by the y value. So for us here, the x value is negative a half divided by the y value, which is root 3 over 2. The 2's divide out. So we should get negative 1 over root 3. Again, so if we want to check if we're right, we would use the identity that the cotangent of an angle is 1 divided by the tangent of the angle. So let's do 1 divided by the tangent of 840, negative 0.57735, and then also negative 1 divided by the square root of 3. Same. Okay, cos of negative 225. So it's going to be the same as the cosine of an angle that has the same terminal arm. So I would say it's going to be the same as a cosine of negative 225 plus 360. So the cos of negative 225 is going to be the same as the cos of 135. Which we know is the exact halfway point in here, in quadrant 2. Doesn't look quite halfway. I'll try it again. Here we go. So negative 225, so there's negative 90, negative 180, 45 more to negative 225. And then this angle alpha in here is going to be, so between 180 and 135 is 45 degrees. So we want our 45 degree special triangle. So R is 1. X and Y are both 1 over root 2. And then their signs depend on what quadrant we're in. So in the second quadrant, it makes sense for the x to be negative and the y to be positive. So from 0, 0, you'd go left 1 over root 2 and then up 1 over root 2. So then cosine of 135 is the x value divided by the r value, so negative 1 over root 2 divided by 1, which is just negative 1 over root 2. Okay, and again, we can check it. So cosine bracket negative 225, negative 0.707106, and then negative 1 divided by the square root of 2, same. All right, cosecant of 510. So that's going to be the same as the cosecant of 510 minus 360 if we want to know where to draw it. So that gives me 150. And we know the midway point was 135. So 150 is going to be closer to the x-axis. Closer to 180. So here's my angle. Oh, sorry, I've got to draw 510 here. So 510 is all the way around once to 360, and then 150 more to get to 510. So there's my angle. And then make my right triangle so I can label the 3 sides of the angle. So this is 150 and this is 180, so this is a 30-degree angle in here. And so for the 30-degree right triangle, the x is going to be either positive or negative root 3 over 2. So in the second quadrant, it makes sense for x to be negative root 3 over 2. R is 1. And the y value, it makes sense for it to be positive because you'd be going up and 1/2. And cosecant is r, which is 1, over y, which is 1/2. Put an arrow there. So 1 divided by 1/2 is the same as 1 times 2 over 1, which is 2. So cosecant of 510 is 2 we got from using special triangles. And we would try 1 divided by the sine of 510 to see if we're right. 2. Excellent. All right, secant of negative 690. So first I want to know where to draw it. So negative 690 plus 360 is still going to be negative plus 360 again. Will tell me where it's going to go. So negative 690 plus 360 plus 360 means it's going to end up at 30 degrees. It's easy. So to show negative 690 though, I'm going negative 360 and then all the way back around. So here's negative 690. It's not all the way twice around because that would be negative 720. I draw on my right triangle with the positive x-axis. And we know that it's going to be the same as the sec of 30 degrees. We know this angle in here is 30 degrees, which means my r is going to be 1. According to the 30-degree special triangle, x is either going to be positive or negative root 3 over 2. It's going to be positive in the first quadrant, and y is also positive in the first quadrant. And sec is r over x. So that's going to be 1 divided by root 3 over 2 or times 2 over root 3 and multiplied by the reciprocal. So 2 over root 3. Well, let's check that on our calculator. So the way we would have to do it is 1 divided by the cosine of bracket, so negative 690. We get 1.1547. And then let's try 2 divided by the square root of 3. Also 1.1547. Okay, so that's how you use special triangles in order to find the exact trig value of an angle. Okay, so you're gonna draw the picture, figure out whether it's related to the 30, 45, or 60 degree triangle, label the sides according to what quadrant you're in, and then use the 6 trig ratios to figure out the exact value. Right?